I'm James Maynard, and I'm a mathematician at the University of Oxford who works on prime numbers. All whole numbers are built up of prime numbers multiplied together, so for mathematicians like me, prime numbers take this fundamental role of like atoms that make up all whole numbers. But the really interesting thing is, despite them being these fundamental building blocks of numbers, they're still really poorly understood, and there's lots of basic questions about them that we haven't been able to answer, even though they've been studied for thousands of years. I'm always drawn to simple to state mathematical problems that have exceptionally difficult and interesting answers. For example, one of my favourite problems in mathematics is the twin prime conjecture that asks if there's infinitely many pairs of primes that differ by just 2. This is a really famous problem that mathematicians have considered for well over 100 years, but we still don't know the answer to it. So one problem I worked on was showing that there's infinitely many prime numbers that have none of their decimal digits equal to the number 7. It's a very rare property for very large numbers to have no 7s in their decimal expansion, and there's lots of really important problems about prime numbers that ask whether there's infinitely many primes that have some rare property. So this is a proof of concept in that direction. It's an interesting problem because you can consider weak variants of the problem, and I'd proved a weaker version, and I've been working really hard to try and get to the full version of the answer that I wanted. When I finally solved it, I was really happy that I was able to finally get over this obstacle because I've been stuck for several months. But at the same time, I was actually a bit concerned because I was worried that I was going to embarrass myself in front of everyone if there was a mistake in my work.